and welcome to my channel. In this video, we will solve the first exercise of the session 2015 concerning determining the focal length of a converging lens L1. For this, we have the object AB of size 4 centimeters. On the graph, you can see that it's represented by 2 centimeters because on the y-axis, we have the scale that each 2 centimeters are represented by 1 centimeter. We also have the converging lens L1 that we aim to find its focal length. We have the screen E and we have set of converging lenses of non-focal length. To find the focal length of the converging lens L1, we place the object AB perpendicular to the optical axis of the converging lens and at distance 60 centimeters from the converging lens. On the graph, you can see that AB is placed at 1, 2, 3, 4, 5, 6 centimeters away from the converging lens graphically because on the x-axis you have scale that each 10 centimeters are represented by 1 centimeter on the graph. On the screen, we also have the image A1B1 of the object AB as obtained by the converging lens. And finally, we have this ray that starts from B and passes through O. In the first exercise, we want to redraw with the same scale the above figure on the graph paper. Let's go back to the figure. To redraw the figure on the graph paper, you draw the converging lens L1, then you draw the optical axis that passes through the optical center of the converging lens. Then you move 1, 2, 3, 4, 5, 6 centimeters graphically away from the converging lens and place point A. Then AB is perpendicular to the optical axis. AB is represented by 2 centimeters graphically. On the other side of the lens, you move 1, 2, 3 centimeters graphically to draw the screen E. And then you draw this ray of light which starts from B and passes through O and hits the screen at point B1. A1B1 is the image of AB and it's represented by 1 centimeter on the graph. The ray BO emerges from the lens without deviation. Justify. The ray BO continues undeviated because it passes through the optical center O. Any ray that passes through the optical center O continues undeviated. The ray BO passes through the optical center O, that's why it continues undeviated. In this part, we want to specify the nature of the image A1B1, and specify means that you have to indicate and justify. The nature of A1B1. So is it real or virtual? A1B1 is a real image because it is formed on the screen. In this part, we want to give the size A1B1 of the image A1B1. A1B1 is represented by 1 centimeter on the graph, but on the y-axis we have that each 2 centimeters are represented by 1 centimeter, so the size of A1B1 is 2 times 1, which is 2 centimeters. In this part, you have to determine the distance T1 between the lens L1 and the image A1B1. The distance D1 between O and A1 is represented by 3 centimeters on the graph, but on the x-axis we have that each 10 centimeters are represented by 1 centimeter, so this is 3 times 10, OA1 equals 30 centimeters. Using a particular ray, determine the position of the image focus f1 of the converging lens L1. In this part, we want to determine the position of the image focus f1 by using a particular ray. When you want to determine the position of the image focus f1 using a special ray, you will think of the ray that is parallel to the optical axis because this ray continues passing through f prime. So let's draw a ray from B that is parallel to the optical axis. Any ray parallel to the optical axis continues passing through f prime, but we don't have f prime yet. So how do we continue this ray? This ray starts from B and then reaches the lens at point I. Any ray that starts from the object continues passing through its image. So we will continue this ray until it reaches the image B1 of point B. The intersection of this ray, IB1, with the optical axis is the image focus F1. In this part, we want to deduce that the focal length of the converging lens equals 20 centimeters. Let's go back to the figure. The focal length is the distance between O and F1. It is represented by 2 centimeters on the graph, and on the x-axis we have a scale 10 centimeters, so 2 times 10, the focal length F equals 20 centimeters. In this part, we want to determine again the focal length of the same converging lens L1 by using different approach. For this, we remove the converging lens L1 from the previous setup and we use different converging lenses of non-focal length. We will keep the object A, B as it is and at the same size and at the same distance from the converging lens. When we use different converging lenses, each one of different focal length F, then you will obtain different distances between the converging lens and the image A1, B1. For different converging lenses, we will measure the distance D, and then we will draw a graph that represents the variation of the distance D again between the lens and the image as function of the focal length of the converging lens, and we obtain this curve here. And the first question of part 2, we have to indicate whether D increases or decreases when the focal length increases from 10 centimeters to 40 centimeters. Then we have to justify the answer by choosing 2 points from the curve. In this part, we want to see if the distance D between the image and the converging lens increases or decreases as the focal length increases from 10 to 40 centimeters. Looking at the curve, we can see that as the focal length increases from 10 to 40 centimeters, the distance D also increases. It means that the image is formed further away from the lens. Let's take 2 points to justify our answer. So for example, when the focal length was 20, the distance was 30. When the focal length increases to 30 centimeters, the distance is 60 centimeters. As you can see, when the focal length increased, the distance D increased as well. In this part, we want to determine again the focal length F1 of the converging lens L1. Some students will be confused here because they will think that we already determined the focal length of the converging lens L1. Notice that in this exercise you have 2 parts. In each part you are given a different method or approach to find the focal length of the converging lens. In part 2 you have to refer to the given that you have, that is the curve that you are given to determine the focal length of the converging lens. In this part, we want to determine again the focal length of the converging lens L1 that we previously used. From the first part, we know that the distance between the converging lens and the image A1B1 was 30 centimeters. Looking at the graph, we can see that when the distance is 30 centimeters, the focal length is 20 centimeters, and this is a matching result from the previous exercise. This is everything for this video. If you find this video useful, please share it with your grade 9 friends, and I'll see you in my next video.